Good afternoon. So here we are at the end. I'm going to be the last probably talk you'll get this weekend, and hopefully you'll find what I have to say pretty much of interest. Give you a little quick introduction of myself. My name is Yahn. I'm the lead networking engineer on Team Fortress 2 over at Valve Software. I was sort of one of the key engineers on Half-Life when we were looking at what we were going to do in the online space, and I also did a whole bunch of other technology for it. The oddball thing about my background is that I actually was a patent attorney for about 5 years. I have a degree in chemistry. I have a law degree. I wrote a Quake level editor that was really popular, and then I ended up getting hired by Valve to do network programming. So it's sort of taken me a long way to get where I am now, but I'm certainly having a really good time with it. And it's going to be interesting to share some of the experiences we've had with the Half-Life and Team Fortress Online community. We certainly didn't expect it to grow to the level it's grown, but we built in a whole bunch of things in case it did. We still are seeing a lot of those things come to fruition today, and we certainly have a lot of plans for the future. So without further ado, I will launch into my slides here. I've introduced myself, so let me tell you about the scope of this talk really quickly. Although I have a whole bunch of knowledge in my head about in-game networking, what we're really going to define the scope to be is to all of the network traffic that is not in-game networking traffic. And there actually is a whole bunch of stuff that's not related to in-game networking if you really want to provide the services for your customers. I'll go through in detail a couple of examples. One I would consider a basic example. It's a gaming master server. We'll get into a little bit of the requirements for what that is and how you might want to implement it. There are certainly other ways to implement it, and there's always the option of outsourcing that. We'll talk about a more advanced service, which is the authentication service, which we use in Half-Life. There certainly was a lot of commotion when we came out and required authentication for playing online. There was a pretty impressive social engineering campaign by the hacking community to try to get us to turn that off. We resisted that successfully, and boy, did they quiet down quickly. So I'll tell you a little bit about how that's designed and how you might want to think about integrating that into your product. I'll talk about some other additional services, time pending, and then I'm going to leave a little bit of time for a wrap-up and some Q&A. So without more delay, let's talk about a gaming master server. As you design your games and you're thinking about sort of what the online space is going to look like, at least for the first-person shooter genre, you really, when you're talking about online, need a way for users to find out where the games are. And so essentially you need a service where you can have servers report to it. So say, hey, I'm a server, I'm alive, I'm still alive, or I'm shutting down for now. And you also need that service to be able to receive queries from clients and respond with the list of active servers. So it's really sort of a database backend that we're talking about. When you're thinking about the design, though, you need to be really cognizant of a whole bunch of concerns. I happen to list security and what I call denial of service attack concerns at the top of the list, just because, as we found out with Half-Life, if you end up being sort of at the top of the list, you end up being a really nice target for people. And so you'll want to sort of design this service so that it's really hard for rogue people to sort of flood your server out with bogus server entries, or for rogue users to just basically flood the server with all kinds of things. And also for dealing with failure cases, of course, that's another important concern of how you design your back-end services. And also, there's a large component of this that has to do with client integration. The whole point of a successful online platform is that the usability from the user's endpoint is enhanced. So if you have only one server in the world and it goes down and your users can't play online, well, that's just totally unacceptable. You have to make a decision about how rigorously you want to go for like 24/7 availability worldwide. That gets really expensive when you get up above about 99.5% availability of your server. So dealing with failure cases in a robust way is a really critical thing. Outgoing traffic. So let's talk a little bit about this gaming master server. Incoming traffic to the master server, there are two kinds of traffic you're going to get. You're going to get servers reporting that they're alive. What do those messages need to look like? Well, they're pretty simple messages, right? You'll probably end up, and we'll talk about this in a little bit, using UDP packets and just sending them off from the server saying, I'm alive. That can be encoded in about 1 byte. You may want to pad out that message with a little kind of a token that we use to differentiate it from your in-game traffic if you're if your responses are going to be coming back the same way. So I'll talk about what kind of pad we use as well. And you have to think about your UDP packet headers, of course. UDP and IP together will add about 28 bytes to every packet. So for the Half-Life community, we have, on a typical day, about 2,500 active servers out there. And we sort of set an interval between how often they send a keep alive message to be about 300 seconds. So if you do the math on that, the master server is receiving these keep alive or initiation messages. It comes out to something like 8.3 of these a second, and it's only about 300 bytes a second. Okay, a 56K modem then would be a great thing to put this master server on. Well, that's certainly not the end of the story. There's a little bit more traffic coming into the master server. Actually, I have these two out of order. Sorry about that. Coming into the master server, and that's the queries from the users. All right, so what does the user want to know from this master server? He wants to know the list of all available servers. Okay, that's a pretty simple query. I send a UDP packet that says, give me the list. Half-Life, 2,500 servers. How do you encode that? Well, they're IP addresses, so if you're not going to be totally aggressive, you can say it's 4 bytes for the IP address and 2 bytes for the port. You can take advantage of a little coherency and compress that a bit more, because most of our servers operate on a well-known port. You can scrunch that number down a little bit more, but not too much more. So 2,500 servers at 6 bytes each, that's about a 15K packet you're going to get back. That doesn't really work really well on the internet. A lot of routers out there they don't handle packets over a certain size. This is something we found out the hard way. We had initially encoded actually an 8K packet as the maximum size. I don't know where that number came from. It was a bad number. After you get to about 1,450, 1,470 bytes in your response packets, things on the net tend to throw them away. So you end up having a really bad catastrophe there on the outgoing flow of traffic back from the server. So you have, on a typical day for Half-Life, you have a whole bunch of users out there querying the server, and let's figure out how much load the server is actually going to see. Let's say this is really typical. 10,000 simultaneous users playing Half-Life, maybe more. They're probably jumping in, refreshing their list quite often. Let's be really intense about this. Let's say they refresh their whole list of servers from the master server every 15 minutes. Well, if you do the math on that, you end up having a load of like 166. Let's see. No, it's 1.3 megabits per second. Okay, you've saturated a T1 line basically. And that's a pretty extreme case, but that's certainly not unheard of. So the outgoing load is sort of something you have to really consider. As a game developer, do you want to host this service in-house and then have to order another T1 line and pay for it? A lot of T1 lines are burstable to 1.45 megs, but they actually sort of crap out at about 128K after K-bits per second after a few minutes. They just sort of disconnect you from the frame because they think you're being bad. Another thing we ran into at Valve. There's certainly some big pipes out there that you can use for a master server. That in and of itself is not going to be sufficient to protect you. I don't know how many of you follow this. Back in January, id Software, the makers of Quake 3, really popular online game right now, well, there was sort of a denial of service attack launched against them, and the attackers were actually able to saturate 2 T3 lines that were being used for the master server. So, you look at what happens with Yahoo and eBay these days, and those guys get attacked by sort of distributed attacks, and that's a really worrisome thing, and there isn't too much you can do about that kind of attack, except hope that the hackers like your product and don't really want to attack you that bad. How are you going to keep rogue servers off of your master? Well, there's a simple way to do it. If the concern here is that you're going to have somebody just send "I'm alive" messages to your master server from spoofed return addresses, and you just end up with like 100,000 of these servers that don't actually exist. So, sending that list out to clients, of course, is going to take a long time and use up a lot of bandwidth, but it's really going to frustrate the clients because most of those servers are going to be unreachable. There's a really simple mechanism that you can use to at least sort of weed out most of these guys, and that's to not allow a server to be listed without doing what's called a challenge and response. Essentially, you trade a little bit of your processing power to handle the challenge and response phase, and then as long as the server passes this challenge and response, you allow it to be listed. There's a more sophisticated way, which is related to what we'll talk about later, called a peer login, where you use actually cryptography to issue a digital certificate, and you use the certificate between the master and the client. That's a much more sophisticated way. That's another way to do this. It's really just a really beefed up challenge response. How do you do a challenge response? Well, I simply send a packet that says, I'm the server, I send a packet that says, hey, I want to be listed on the master. The master says, well, you look like you're coming from IP address X. I just send a random number back to that guy and say, send me the real keep alive message with that random number. And if I don't get that number back from that IP address, I know that guy was fake, I don't list him. That's the simple way we do it. Scalability, sort of one of the issues that you always will need to consider when you're designing these back-end services. The United States, at least, is notorious for having sort of this meltdown of the backbone between the East and West Coast. So if you have all of your back-end services sitting in one data center on one side of the country, and it's critical for people to get to that data center, well, you're going to be hosed more often than you really want to believe. So what do? You need to have a scalable system. You need to have separated servers. You may want to, if your load is too high, actually put even redundant servers behind one IP address with a load balancing system. You need to, if you have separate servers, you need to have some way to keep the data in sync between those servers. So we'll talk a little bit about replication and peering in a bit. So, if you're going to host this service yourself or design it, always think about scalability. Always assume that you're going to have a lot more users than you think you will coming out of the door. So I talked a little bit about these really large responses, 15K packets. You just can't do that. All right, there are a couple ways you can handle multi-packet responses. As in, that data really needs to be split into packets that are 1,500 bytes or less. The first way is to sort of have the master server run a session for you. What it does, it says, okay, this guy can't get all 15K at one time. I'm going to send him 1K, and then a second later I'm going to send him another K, and I'm just going to stream these pieces of data out to him. That can be good and bad. The thing about it is you have to make some assumptions about the capacity of that guy's connection. If he's on a 28.8 modem and you're sending him a packet every 10 milliseconds with 1,500 bytes in it, he'll probably get disconnected from his ISP and his modem will blow up, especially if it's like a WIN modem. So that's not necessarily the best way to do it, but it's viable. Okay, how would you solve that problem? Well, you may embed into the initial request some indication as to what kind of capacity I have. Don't send me more than 2,500 bytes per second. That's totally viable. The way we do it is a little bit different. We actually do this in batches. What we'll do is say, okay, send me the first batch of servers, and in the response for the first batch of servers, it'll say, well, I sent you servers 0 through 700. Okay, and there are more servers. Okay, give me 701 on. Give me 1,401 on. Are there any more? There are no more. The nice thing about that kind of a scheme, when you think about it, is that you don't have to worry about the flow control flooding issue. It's a self-regulating system. If the connection back to me doesn't have the capacity to receive the data, the packet goes away, right, and I have to resend and re-request it. And I also won't request the next segment until it's totally cleared and come back to me. So that's a really nice system. The downside, of course, is that you do have if you're on a really latent connection to the master, you have an extra round trip time in there for every packet that you're sending out. So it's something that we thought about and decided we could live with. Another way to reduce the amount of traffic that you're getting back from the master server, of course, is to allow sort of some kind of querying system. So to really treat the master server like a database. So when the keep alive message comes from the server can also say, well, actually, I have a capacity of 16 players and there are 15 on right now. And then when the client queries, the client can say, give me the list of servers, but hey, don't send me servers that are empty or full. I'm not interested in playing on those. That'll restrict the number of servers you get back, but for the most part, you still are going to run into this packet size limitation and end up doing some kind of batching system. Of course, that's only with UDP. If you use TCP, you can probably get the data in a stream. And I think GameSpy uses TCP for the requesting of serverless. So architecturally, there's some decisions we'll talk about later. Well, we'll talk about now. So just a little primer on the two major transports that you can use to do this kind of querying. TCP, Transmission Control Protocol. It's a connection-based protocol. It's reliable. The downside to it is that it requires a dedicated port for the connection. If you're sending 15K worth of data, that can take a couple seconds to get across. So you've got to dedicate that port for the whole time. Although you don't have to worry about flow control and how big the data is. So that's a nice part of it. UDP, on the other hand, is a totally unreliable protocol. I mean, you send the packet off and it's in la-la land on the internet. There's no guarantee it's going to get there, that it's going to get there ahead of other packets, that it's not going to be duplicated along the way. Packets are smaller. You have to worry about a lot more issues with UDP. It depends on what kind of server you're dealing with. Like a master server for us was a server where if we lose a packet, no big deal. The client is usually the one requesting something. It'll just request again after a few seconds. If a heartbeat or a keep alive message to the master server gets dropped, no big deal. We'll send another one in 5 minutes. You want to keep those servers online, listed in the master for longer than the interval between one drop packet, but that's the only real restriction on it. There's sort of a hybrid approach where, and this is really sort of more pertinent to doing in-game stuff, but if you're going to do chat or something, you might look at doing something with what I call reliable UDP. And I'll give you sort of just a really cursory overview of how you might do that. What is reliable UDP? Well, it's sort of like TCP, but it doesn't have the really bad performance characteristics that TCP usually has, the nagling and the slow starting and the fall off. So how would you do a reliable UDP stream? Again, the whole bad thing about UDP is that you can get drop packets, out of order packets, and duplicated packets. All right, how do you know any information about a packet? How would you know that these things happened? Well, you pretty much have to put a sequence number in the packets. You actually, to know on both sides of a connection, a reliable UDP connection, what's going on, you need sort of the packet I'm sending you. So every packet I send, I increment a counter, and that's my outgoing sequence number. And I also need to send the other side an acknowledgement of the last its side outgoing sequence number I got. So that way you have a message pump, and you can just look at what's coming in and say, was this message greater than the last one I got? Because if it's equal or less, I know I'm either duplicated or out of order. I can throw the packet away. And if it's more than one greater, I know I've dropped a packet, but hey, what am I going to do? I'm just on the receiving side of this. But that's how you know whether to just discard packets. How do you do a reliable payload with this? Well, you essentially use a simple on-off toggle. You have a staging area of data. When the data in the pipeline has cleared out, you move the data from the staging area over into the pipeline. You flip this bit, you mask it into your sequence number somehow or stick it on the end, send to the other side. If you ever get a packet from the other side with a sequence number greater than where you sent that doesn't acknowledge the yes-no bit correctly, you know that your payload was dropped. Send it again. Otherwise, if you get a packet back with the acknowledgement correct, you can clear out your payload, bring the next one in. That's reliable UDP in a nutshell. It's actually sort of complicated to get going correctly, but once you do, it's a really useful protocol to use for all kinds of things. All right, so we made a decision to use UDP for the master server. Because we weren't that worried about losing packets. We weren't worried about consistency of data. When I say consistency of data, think about it this way. I'm telling you that you're probably going to have to use a multi-part response for getting your packets back. So there could be a server that shuts down halfway through the response, or one that comes alive earlier in the response sequence that you're not going to see. You just don't get that data. Does that really matter if there are 2,500 servers out there and you only get 2,478 of them? No, it doesn't really matter, at least to us. UDP also is really capable of, it doesn't have the overhead of one socket or one port per connection to it for a query. Everything can come into one port and we can just handle it as fast as possible. And also, just looking at the nature of the data, these really are sort of, the queries are really datagram oriented. They can be packed into one contiguous piece of memory. Some failure cases to think about, timeouts and race conditions. So, I send a query to the server and I don't get a response. What do? Well, I need to resend the request. There's some really basic ways to do this. One of them is to, when I sent that request off, to keep that buffer around and just have the network layer say, I never got a response for that, send it again. The other way, of course, is to say at a higher level, I never got a response, reconstruct the request, send it again. You do that X number of times. If you don't get a response at that point, you can assume failure. If you assume failure of one master, you would obviously roll over to the next master, use it. Eventually, you have to give up at some point. How many seconds do you want to make your users wait to get this information? It brings up a really interesting problem that we ran into, which I call the 1 millisecond ping problem. If anybody remembers the original Half-Life front end, we actually integrated a server browser into it. I think we were one of the first companies to do that. And it had some problems with reporting the latencies to servers. The problems actually arose out of what's really a race condition. And what I mean by race condition is that I send a request off to somebody, and I wait, and I think I've timed out, and then I go ahead and resend the request, and at that point I get the first response back. So if you're trying to determine the round-trip latency to a server, and you send this raw ping request off, send a ping, oh, I timed out, send the second ping, get the response to the first one a millisecond after you sent the second one. What's your ping? It's 1 millisecond, right? That's a huge problem. That's a race condition that you have to avoid. Okay, how are you going to avoid this race condition? Well, there's a simple way to do it. It's sort of to associate a context with your request. In a lot of ways, this is like a sequence number. It doesn't necessarily have to be a sequence number because it's really a one-way communication. But essentially, I say ping, I stick a random number or some number I keep incrementing on there, and the response back to me has that number associated with it. So I can know that what I'm getting is this stale response to the first request, or that I'm getting the one to the second request I sent. So lesson that we learned sort of the hard way on that. We had a lot of people saying, boy, that 1 millisecond server really sucked. Single point of failure, just a really obvious thing to avoid. There's so many ways that you can get bitten on this. Nobody can really guarantee 100% availability of things, but if you don't separate your services, at least geographically, you can really have problems. Servers do go down quite often. These servers are very heavily trafficked. I'll talk about statistics in a little bit, just to give a little bit of overview of some of the statistics we've seen. So you have to watch out for that. Scalability, administering servers. Game companies are usually small shops, and they don't. Well, I certainly don't want to be wearing a beeper that goes off at 3 in the morning that says I need to come in and reboot a master server. So there is sort of an argument there that you might want to think about at least outsourcing this function or allowing remote administration if you need to get in there and tweak things. Or if you're actually going to bite the bullet and host a server. A lot of the persistent guys will host them in their data centers and have people dedicated. You want that server on site if you're the one dealing with it. Adding and removing servers. What's the mechanism to notify people that there are new servers? Well, you sort of need like what the OneNet guys will call a directory service that sort of serves out the list of available servers. So it's sort of at a meta level on top of the services that you provide. Some place that you can always go to find the list of available servers. That works really well. Peering of the data. If you're going to be scalable and use multiple master servers, well, you need to deal with the data being sort of in synchrony on all of them. And how do you do that? Well, there's sort of two ways to do it. One is to have the master servers handle the peering. So I talk about this keep alive message from the server. How do I do peering at that point? Well, there's a really trivial way to do it. The keep alive message comes into the server, and their server says, hey, I know about n other master servers. I just send a special message from master server to master server saying, IP address, keep alive message, go, okay? If those packets get dropped, again, we're sort of like not worried about having inconsistency. If they get dropped, they get dropped. They'll give you another keep alive. It'll get propagated to all the servers. The data at that point is pretty much on all of the servers. Any user can query any of the servers. There's another way to do this, which I think is not as ideal, but you can consider at least. If your game servers know about all of the master servers, well, then you can just have them send their keep alive messages to all of the servers. So you're sort of forcing the client end of things to do the peering. I don't think that's as good because it doesn't really allow you to bring more servers online in a really seamless fashion. But that's another way to do it. Load balancing, sort of the same kind of thing. We talk about having servers, talk to all the master servers. Well, let's talk about client queries to these servers. Mistake we made with Half-Life, honestly, is that everybody, the first time they tried to find the list of servers, talked to Half-Life East.1.net. Well, that machine really got torn up by that. And it was because we weren't doing anything to sort of randomize in some way which server we would talk to the first time. So just some simple solutions to that. One is every time I want to talk to the master server, I scramble the list of available ones and just talk to whichever one I can. Again, if you fail, you roll over to the next one, roll over to the next one. Second way to do it is sort of to scramble it just one time at boot up. You're just looking for random distribution here. And the third way to do it is actually to have a load balancing system at whichever one you talk to the most. Again, you don't have the true scalability there, but you can route the requests to different servers behind this one front end. So I just want to give you sort of like, what do you do with this list when you get it? Okay, this is something that the GameSpy guys are really good at. Essentially, you need to go through that list and send queries to the servers. In the sort of the Quake engine community, servers are looking for a certain format of query, essentially a give me your info query, and that is delimited from a regular in-game traffic message by prepending a tag onto every sort of what I would call an out-of-band packet to that server. And that's why I say that the queries that we do all have this little tag on them, and it ends up being 4 bytes of 255, or essentially a -1 that's a 32-bit integer. This is a really common thing for the Quake games, and it helps the server differentiate sort of this external request from in-game traffic, something to think about when your servers are being responsive to game traffic and this back-end traffic. Flow control. Okay, I've got 2,500 servers. Okay, I'm going to send off 2,500 requests right away. I'm on a modem. All right. Well, first of all, it's going to be hard to get those requests off, but boy, when I get those responses back, I'm just going to kill myself. How big are the responses? Well, I think the half-life responses, are 150 to 300 bytes. That's pretty typical from each server. So you have to be really careful about how many requests you meter out. There are a bunch of ways you can handle this. Have n number of sockets in threads, allow the user to crank that up, but ship with the lowest possible denominator on that. Look at the size of the packets you're getting back and adapt how many sockets you're going to use or how many responses you're going to have pending. You don't have to use threads. You can do this in a state machine. It depends how you're going to do it. Response formats, another thing to think about when you're building your servers is how to do the response formats in an extensible way. We didn't do this in Half-Life. And so when you say, give me the info about a server, you get, in a really specific order, the map name and the number of players and what operating system it's using and stuff like that. That works fine unless you want to change that data. Let's say I'm really interested at some point in finding out about some other piece of data about the server. It doesn't really matter. A better way to do it is probably to have some sort of open-ended format for the responses. You can do, there are a couple different ways to do this. Key value pairs are just the most straightforward way. I send you back data, but it says, map name, name. And then I can just add parameters, and you know how to parse them. You can do this with null-terminated strings for the keys and the values and a double null at the end. You can do it with a delimiter, like a forward or backslash between things, with the obvious restriction that you can't use forward or backslash in the keys and values. Something to think about. That's a totally open-ended system, right? I can change what data the servers come back, and I don't have to change the protocol. Really hard to change protocols after you ship, although we've done it. All right, that's the basic service, and you'd think for something so simple it wouldn't require this much talking, but there's actually a lot of things to think about. One of the more advanced services that we decided we really wanted when we shipped Half-Life was the authentication service. So we'll talk a little bit about that. So we were really concerned that we were concerned on two fronts. One was the obvious piracy concern. We're going to use a CD key. Let's use that key to restrict the access to legitimate purchasers. That worked really well for us. The other concern we really had was about cheating, and I think that's sort of an understated concern. A community like the Team Fortress and Half-Life Online community suffers really heavily when there's cheating that the game developer doesn't really try to take care of. And the most obvious kind of cheating that happens is sort of hacking the binaries and changing the versioning and proxying the protocols and stuff like that. And so we took a look at that, and that's one of the motivations we had for implementing an authentication server. So what are we talking about? Well, we're talking about cryptography. This may or may not be something that, as a game company, you really want to or have the capacity to get into, but we'll talk about it anyway, just so you sort of have a flavor for what we can do with it. Cryptography, the way we use it is it's really a glorified challenge response system. We actually end up using public key, private key, symmetric cryptography, digital signatures, and verification, all of those things. If you want to learn all kinds of things about this, I highly recommend Bruce Schneer's Applied Cryptography book. If you want to know sort of the flavor of the protocol we actually use, do some reading up on Kerberos, with the caveat that they're really sensitive to synchronization of clocks. We aren't that worried about that particular issue. If you have an authentication service, what does that mean? That means that users who want to sort of get into the system at any entry point get what's called a certificate. And essentially a certificate is sort of that the authentication server, which everybody trusts, and we'll talk about why that is, has validated this is a legitimate user. What does that mean? They're not hacked and they have a valid CD key. That's what it means for us. Just a little cryptography point one, because I'm certainly not the expert, and I'm certainly not going to be teaching you about cryptography. When I talk about a symmetric key crypto system, what I mean is a crypto system where the same key is used to encrypt and to decrypt. They're the identical key on both sides. When I talk about public and private key systems, on the other hand, what you have is a pair of keys that are correlated to each other. What I do is I give you my public key, you encrypt with my public key, only I can read messages using my private key. I don't give out my private key. It's for me. What's a signature? Well, a signature is I use my private key to mark a piece of data, and then you use my public key to verify that I actually marked that piece of data. So it's a checksum that you can use my public key to say, yeah, that's actually a legitimate message from this person. So the first thing we need to do is talk to our authentication server and get sort of the current public key to use to validate certificates. Well, somebody could implement a rogue authentication server if we didn't have a way to, what I call, verify that the auth server was legit. So we actually ship a key on the CD that we use to verify messages from the auth server. We obviously need to periodically update. We've done that in Half-Life a couple times now. Obviously, the update frequency depends on the size of the key space. You may not have to go to like the heat death of the universe length of time, but a few years is probably the lifespan that you want for such a key. So when I'm requesting the public keys from the auth server, what I do is use this verifier key that I've shipped with to verify the response I get from the auth server. As simple as that. Once I get the public key from the auth server, since I'm sure I've verified that it's from the auth server, I can use that to validate certificates I get from clients. So if I'm a server and a client logs into me, I can use that public key to validate the certificate that we exchange, and I know that they've authenticated also. It keeps the rogue guys off of the servers. What's a certificate? Well, a certificate is simply a public key and some unique user data signed using the private key of the auth server. So when I say signed by the private key, it means that the public key of the auth server that I know I have, I've gotten it and I've verified it, can be used to validate the certificate. How do I request the certificate? Well, I need to send some data up to the auth server, and I need to send him a secret that I want him to use to talk to me. So that's what I call the session key. So I encrypt a few things. Actually, I encrypt my CD key because I don't ever want to send that plain text. I send that and the session key up to the auth server. And then I get a response back, and hopefully it has the same session key. The auth server has my public key, so it's encrypted this response back to me, and I use both to decrypt the message. It'll send me a failure case if my CD key doesn't match. Let's talk about CD key systems sort of as an aside here. Some games out there have used these. I think StarCraft or Warcraft or one of those was the first one to really heavy-duty use a CD key system. And they had a fair amount of success with that. The really key thing that we found in our experience is if you don't have sort of this simple client-side typo check on a CD key, your support bills are going to go way up. I think this sort of happened in a bit of a way to id when they had alphanumerics, and it was a little unclear whether you needed to type in upper or lowercase. Having a typo check that's sort of part of the CD key is a great way to solve that. The thing you don't want to ever do is ship the code that validates the full CD key on the client. It will be hacked. At Valve, I can honestly say that I have no idea what the actual code is. We intentionally segregated ourselves from that code. I don't know how to validate a CD key. We outsourced the production of the CD keys to OneNet. They're the only ones who actually know. The weakness there is, of course, if that gets compromised on the back end, you're sort of hosed. The other thing about CD keys, we stored them in the registry. Other users or other software houses have stored them in data files. Consider storing them not in plain text. And the anecdote I have for that is what I call the infamous Half-Life 1.0.07 update, which never actually existed, although there was a clever user out there who announced the downloadability of the 1.0.07 update to Half-Life. Well, this was just sort of a Trojan horse that would look through the registry and try to rip CD keys. Unfortunately, fortunately for us in some ways, the gentleman who did this happened to not send the ripped CD keys to the correct address, so they were sort of lost in space at that point. But it's a very interesting issue. It's sort of amusing to see him sort of saying, "I'm such an idiot" on IRC about that, and somebody captured that and sent it to us. So be really careful about how you store your CD keys. Just don't make it trivial, I think, is sort of the lesson there. CD keys aren't the only way to validate users. You can obviously go with usernames and passwords and use the cryptography to send those things. Again, avoiding sending plain text of the critical information is the key. Another thing we do besides the CD key during the request for a certificate is look at the executable and the version number on the executable and make sure that the user's up to date. So this was really a convenient place for us to hook into our auto update backend service. Some things we learned sort of after the fact that make it really hard for us to rev this protocol is that we don't do the version checking until we're well into the cryptography. So in some ways, we don't have a real good mechanism for changing this. It would be painful for us to do that. The other thing to worry about is if you're looking at executables and checksumming them, you need to randomize it in some way. Otherwise, somebody will find they'll basically write a proxy that inserts at the right spot the bits that correspond to the checksum. All right, so some way to randomize internal data structures, however you want to do it. That's something to think about. The final thing we ran into, which is also sort of amusing, is when we shipped Half-Life, we didn't have this, and we had a lot of people whose executables wouldn't work, even though they said, they claimed to be legitimate users of the system, and we believed them to be. And it turns out we would always ask them the question, hey, have you checked for viruses? Oh, yeah, we checked. I have the latest, Norton, and we checked. We didn't, nothing. Send me your executable. Okay. 10% of our users approximately had the CIH virus, and they weren't up to date on their virus checkers. They get really apologetic when we tell them that. It's like, thank you. I had 4,300 files on my hard drive infected with the virus. There's a simple solution to this from your point of view, and it doesn't require cryptography or anything. Ship a data file with each executable that you put out. That's basically a checksum of the data of the executable. When you run the executable, checksum yourself, look at the data file, say, hey, something's different here. So what do you do with the certificate? Well, you can use it to log into any of the backend services, also to log into game servers. How do you do a peer login? Well, this is sort of going to be a little complicated, so I would encourage you, if you really don't digest this the first time, to read the Schneer book, send me email. Mike Nicolino from 1.net here, I'll give his email address. He's an expert in this also. He'd be happy, I'm sure, to answer questions about how this basically works from a cryptography point of view. What you do is you get into an exchange where both sides need to have a valid certificate. So you send your certificate to the peer. Certificate, again, has your public key. It's what they use to encrypt messages to you. Peer responds, sends you a secret, that's just for that session, a secret token and his certificate or her certificate. You obviously, they've used your public key, so you're able to decrypt this message. You have to send back the secret. You have to use their public key from their certificate to send it, and you send them your own secret. And then finally, they respond with your secret token. If it matches up, you're successful. In this way, both parties have validated each other, and the only assumption here is that the third-party authentication server is a trusted source for all of them. So how do we design this service? Unlike the master server for games, this one really begged, because of the ordering issue, to be a TCP/IP session. And we sort of went over this with the one guys when we were integrating about why that was, but it makes a lot of sense. We need guaranteed ordering of messages. Again, you could do this with UDP if you wanted to. You just have a lot more things to track. Again, the TCP has the problem of occupying a port per connection. So if you don't want to get denial of service attacks, you need to make sure that if somebody's sort of just sitting on this connection, that you disconnect them as quickly as possible. So think about timing things out if you're on a TCP backend service at least. Some things about our loading that you might find interesting. On a typical day, we took a snapshot of what the authentication servers were seeing. I think we were seeing 385,000 authentications for the day. And that's just one of the two back-end servers that we're looking at. And that works out to 4 or 5 authentications per second. That's a pretty substantial load. I think our numbers have gone up. They're almost twice as much as they were at that point. So these are workhorse machines, and you need to consider that when you're choosing how to design them. Let me talk about another sort of back-end service that we're going to be coming out with pretty soon. It's what I call a tracker or buddy list service. When we look at gaming, with the server browser, it was straightforward to us. It's like, well, what do users want to do from a usability point of view? Well, they want to find servers so they can play. That's the fun thing. Well, we sort of have always been reevaluating whether that was really what they wanted to do. And, we sort of have a history of thinking social gaming is really interesting. And so we reevaluated this and said, well, you know, what they really probably want to do is find their friends or the guy who killed them last time they played and go after that guy. So let's build in a buddy service. And we can't really use sort of an existing instant messaging scheme because there are some other things that we need to do in this service. Let's just talk about how would you design such a service? You really need sort of a powerful back end because what does a buddy service do? Well, it tracks who's watching me and what's my state and making sure that when I change my state to being in the game or being on a chat server or just sitting idly in the system, that gets propagated to everybody who's watching me. I need to be able to send messages to people, receive messages, invite people to play on servers, etc. You need to do that in a scalable way. This is actually a high traffic type of system. You can't just put it all on one machine and write a bunch of custom code and hope that it works. You really need to design this from the ground up. One thing in any database design for a backend you have to consider is there a way to partition the data so that pretty much everything about a particular user is on one real server that you can hit. That way you can add additional servers pretty easily. And so a design that you might consider for such an issue is to have a load balancing front end, multiple servers sitting behind the front end, having unique user IDs, and then for each ID, knowing which real back-end server to go to for all of the information about that user. Well, what's in that database? It's just the people who are watching me and if their current IP address if they're logged in. And then when I change my state, I just look up in one database exactly what's going on, send a bunch of messages saying state's changed, state's changed, state's changed. That works really well. When's the time that you have to hit all of those back-end databases? Well, the time you have to hit them really is when people log in. When I log into the system, I need to go across everybody that could be watching me and add myself to the I'm watching list and they're watching me list. And so you end up hitting all the servers at that point. You got to do a lot of calculation on this stuff to figure out exactly how you're going to get killed. But that's sort of the general part. The replication scheme and the peering scheme that I'm talking about with multiple backends and partitioning of data, that's the hard part of this kind of a design. So for the tracker service, we've talked a little bit about the other things here. Integration with gain logic, that's the really cool thing about this service. Like if I want to play against my friend, I just click on them and say, go onto their server or invite them to my server. That's sort of a really exciting use of a back-end service. We think that's a really cool thing. Some additional back-end services that you might want to consider deploying. The first one is called a directory service, and I sort of touched on this earlier. It's sort of a glorification of the master server, where what's served out is not just active game servers, but also other available back-end services that you have. Essentially a directory of all available back-end services, be it chat, message of the day, auto-update servers that you might use, mod servers that you might use. Those things are all sort of under the umbra of a directory service. Chat service, chat is a pretty integral part of a lot of people's systems. You look at Battle.net, they put you in chat right away when you go onto their system. They probably have a lot more people chatting than playing a lot of the games sometimes, but that was a really smart move on their part. They also have advertising on that page, which I think is fairly amusing. But chat is a really important back-end service. How would you do chat? I mean, I can give you a few simple ways to do it. There are a whole bunch of different ways to do it. You might be naive in some ways and say, well, why don't I just provision an IRC server and write an IRC client for it? You need to be careful. I think the Tribes guys did this, and they eventually went with a custom solution. The unfortunate thing about IRC is that it's a very, very well known or hacked, I guess is the better word, hacked system. There's amazing stuff that goes on IRC channels. Consider it carefully if you're going to use IRC as your backend. All right, so you're not going to use IRC. What are you going to use? Well, you're probably going to come up with a custom solution. There's a couple of different ways to do it. One is that you treat chats as peer-to-peer connections. Maybe you appoint one of the users as the host. Everybody sends talk to them, and that person replicates all of the messages to all the other people in the chat. What happens when that host dies, drops, decides doesn't want to chat anymore? You can reappoint another person in the chat to be the host, or you can just close the chat session. Design decision, that's up to you. That's one way to do it. The other way to do it is to really have a dedicated client-server model where you have a server that everybody logs into, again, the server is responsible for adding and joining and replicating the messages to everybody, replicating the user list to new users, dealing with users dropping. Pretty straightforward. OneNet has a really robust chat system. You might want to talk to those guys about it. I believe the GameSpy guys also offer a chat backend. I'm not sure if it's IRC-based or not. I think it may be a customized IRC. I'm not absolutely sure about that. Maybe one of them can speak up at some point. A message of the day system. All right, so you've got important news about your game. How are you going to provision a message of the day system? This is actually the most basic example of a backend service you can do. The big issue is like, how are you going to format this data? Are you going to use HTML? Are you just going to have some custom layout language? Are you just going to send raw text down? Other than that, it's pretty straightforward. Make a connection to the master that has the message of the day. Say, give me the message of the day. The only tricky thing is how long, what's the life of these messages of the day? How do I track which ones I've seen and which ones I haven't seen yet? That can be done really simply. Each message of the day that you might send out is incremented sequentially. I remember the last one I've seen. When I log in, I say, hey, I've seen the first 30 messages of the day. And it's like, well, here's 31, 32, and 33. Really simple. Again, if you got to consider whether you want to be in communication with your users. And if you do, I think a message of the day is sort of a critical component. We sort of did this for Half-Life, but never turned it on. In retrospect, I think it was a mistake. It's really nice to be able to talk to all of your customers. Auto-update. Fragmentation of your user base is like one of the worst possible things you can do. I always am, sort of shocked that a lot of the games out there will sort of ship incompatible versions, and you'll have servers that you can't connect to because the protocols have changed, because the versioning has changed, and this is sort of like a really sloppy way to do things. Having the authentication server for us makes this really easy. We know when somebody's out of date, and we will force them to auto-update. Good and bad with that, obviously. We released Team Fortress Classic as an auto-update, 22 megs of it. We got a few messages, less than 5, I think, from people saying, hey, I don't want to download this much stuff just to be updated enough to be compatible. But in some ways, that's a really compelling way to drive things into your customers' hands and to make sure that everybody's compatible all the time. Third-party mods, again, this is just specific to Half-Life, but it's something you should consider. The mod community is really critical to the ongoing life of any game that has a significant online component, and we're really cognizant of this. And historically, at least for the Quake-style games, it's been rather difficult, I would say, to download and install third-party modifications that you want to play. I mean, you had to use your FTP client or a web client. You had to put it in the right directory. You had to unzip it. You had to configure it. All right. Like, we took a step back and said, wait a second, this is not usable. That's totally unacceptable. So what we did was design into our client just a third-party mod system, client side, and there's essentially a master server that lists available mods, where they can be downloaded from. On the client, we just list them out. If somebody wants to install and play a mod, they pick it from the list. We go to the FTP site that we got from our master server, download it, install it, unzip it. We're done, right? The usability issue, I mean, it's just a great thing from a usability point of view. Another back-end service that you might want to consider. You can go all day and think about really cool things you can do on the back end. You have to draw the line at some point and decide how much money you want to spend doing these things. A couple more that we've thought about doing. Video drivers. Anybody in the gaming industry knows that getting your software compatible with the latest video drivers is just nearly impossible. People out there haven't updated their 3D drivers in particular in like a year, and your software doesn't work for them. Well, there's probably a back-end service that can be created to solve that problem. Hopefully somebody out there will be enterprising enough, and it may be something that needs to be done on an industry level. Chris has done a really, really great job with GL Setup. I think sort of having a client component to that where that really is integrated with game software is probably the best next step, instead of sort of being this optional setup that you run. Just make people be up to date all the time. Content searching. Okay, I'm playing on a server and it cycles to a map that I don't have. Okay, do I want to sit there and wait for that to download in-game? Yeah, that works perfectly well, but it's sort of slow. And I'd really like to know, what are the really good maps that are out there? How are they rated? Okay, another back-end service that you can do is a content searching service. The one guys have something called OneSwap that does this from a web-based point of view. Integrating this into your client may be a really good idea. Then you or your users can publish essentially new maps and new sounds and new textures to use in the levels, and there's a way to find them from within the game. It's not that you have to go, again, and learn how to use an FTP client, where to copy the files, how to install them. Taking away that pain from people is what will make the online gaming space more of a consumer entertainment experience and less of like the hardcore community that in some ways it is today. I've talked about a lot of services. A lot of these we didn't do in-house. We just didn't have the manpower at the time, or it wasn't, a cost-benefit analysis on it said, hey, it wasn't worth us doing this. There are different organizations that can help you with some of these issues. Some things you may want to invent in-house, and other things you may want to outsource. You can look at the design of the back-end service, or even the hosting of the back-end service. I would point you to Mike Nicolino's contact info. I think it's up on the slide. If you have questions about World Opponent Network, I think David Wright is here from GameSpy. If you have questions about that, he's down in the front. You can obviously snag him when I'm done. Just a little bit of recap, and I'll be done. So you're sitting down to decide what kind of services to deploy on the back end. You've got your in-game networking working. If you're like a lot of developers, you're 3 weeks from shipping when you're making the decision. That's a mistake. You need to think about these requirements sort of early on. Like, what's the most critical thing for you? What type of game do you have? If you have a persistent online RPG, well, a lot of the stuff I'm talking about doesn't really matter, but a lot of the database and scalability issues do matter to you. What are the requirements for the system? Do I care about loss? Do I care about attacks? How much traffic is the system going to use? Go through the outsourcing decision. Do I want to write the code for this, or do I want to license it from somebody? Do I want to host these servers, wear a beeper, have it be 24/7 in my developer's office? Do I want to have somebody else do that? Do I need an ISP to do that for me? What kind of connections do I need? There are a lot of issues to work through. Instrumentation. Thanks to our efforts and the one guy's efforts, we have a lot of sort of general data about the usage patterns, and it helps us make decisions about what to do in the future, and also critically about when to bring online more back-end services. So certainly when you're designing these systems, make sure that you can get from them historical data about what's really going on, which ones, like when we found the problem of only the first Half-Life East.1.net being the one that we hit every time, that was because that server's log files were just completely choked with data. It was just obvious what was going on. If you wait till the last few weeks, you will have pain. You need to get these things up and running early and test the heck out of them. I say that sort of being the master procrastinator at this. We sort of got a lot of these back-end services online late in the development of Half-Life, and we paid for that a little bit. So think about doing it early, and think about really hitting them hard to make sure that they're doing what you think they're doing. So again, the thing that your users are going to be really impatient to is downtime. You have to make sure that they're at least educated that there will be times probably where they won't be able to play online, especially if you do something like we do, which is require them to be authenticated to play online. You can say, you can not do that trade-off. You can say, if I'm unable to connect to the master server to authenticate, I'm just going to let that player play. That's a trade-off that we didn't make. That's one that you may be willing to make, because that way you don't piss off your legitimate customers when there's just something wrong on the back end or on the net backbone, and they're allowed to play while there's downtime. You're exposed, obviously, but that's a concern. I've talked about ways to do some of these designs. These are ways we've done them, or I think they can be done. They are by no means the only way that you can design these types of systems. Like the gaming master server, it certainly can be done as a TCP session. That can be done. We decided not to do it for a lot of different reasons. At this point, I guess I'm ready to take questions. I'd ask you to come up to the microphones if you're going to ask questions, and I'm a little blinded, so go ahead.
I had a question with regards to the scalability. The big issue I know with a lot of websites is there'll be a media event, for example, something on Oprah, and next thing you know, you get slammed. And it's like the marketing guy is going to tell you, you're on the back end. Is there similar issues in the gaming community with regards to building your back-end servers in terms of, for example, a media event, a radio announcement, or something like that, where you have a sudden peak that just takes you down to your knees?
Yeah,
what to do?
I think in some ways you have to like look at what the worst case can be is and multiply it by 10, because you can't anticipate when the spikes will occur. I mean, if you look at our usage pattern, it's sort of interesting to look at our usage as the day goes by. We really we'll ramp up in the afternoon, like between 4 and 7 o'clock to 16 or 17,000 players, and then at 3 in the morning we'll be down to 3 or 4,000. Well, you better be able to handle those 17,000. And then occasionally we'll have like the user community say, let's see how many players we can get playing Team Fortress Classic on December the 18th. You get this huge spike. So you want to have your stuff deployed well ahead of that kind of thing. I mean, you basically need to have spare capacity, or what's called over-engineering the network, I think, in the ISP world. I think that's something you just have to do.
Have you thought about building multiple servers to have only localized sort of gaming lists? Because when you download this huge list, most of them will be like in another part of the world, so it's...
Right. This is a really good question. We have thought about this a lot. It's essentially a question about, should we regionalize the databases and then only have the Europeans talk to a European master server, only have the Australians talk to an Australian master server, because in the end they're going to connect to the servers that they have a better connection to. That's a great idea. That's probably the way that kind of thing should be designed. There are a whole bunch of schemes for doing regionalization. Essentially, you just need to make sure it's built into your protocol when you ship. That's a really good idea.
Well, no more questions from anyone else, so I'll just ask another one.
Sure.
The big issue I've always found is like trying to pick outsourcing partners, in particular, ISPs, bandwidth, and hosting. Do you have any guidelines that we could use when we start selecting these outsourcing partners?
Well, I mean, you want to sort of shop around and make sure that the people have the expertise to deploy the systems you want. I mean, if you're just looking for a big fat pipe, there are a whole bunch of people that can deliver that. But then you're going to be on the hook for the design and implementation of the systems. If you're looking for somebody who can provide solutions to you, it's going to be somebody like a OneNet or a GameSpy who's sort of been in this business for a while. You need to look at their experience level. Again, the thing about outsourcing, the thing you need to be careful about is not being naive about whether you can do these things on your own. Half-Life has been successful, and we did generate a lot of these services on our own. And in some ways, we were incredibly lucky that we didn't really screw up things more than we did. The guys like the One guys and the GameSpy guys, they've done this for a while now. This sort of industry has matured for them. So I would look to those kinds of guys to shop around at least the outsourcing of the design and hosting, because you really need somebody who knows more than how to reboot the machine when it dies. A lot of these services are a little tricky to get up and running.
Hello. This is just a sort of boring logistics question. I was wondering how long it took you to get the Half-Life backend stuff together and how many people were working on it, and also perhaps what percentage of it was outsourced.
On the master server side, I probably wrote that in a few days. On the authentication backend side, the One guy spent several years and millions of dollars investing in writing those servers. I think you can do it, with a lot less money than that. It may not be as robust, but it may be totally sufficient for what you want to do. So I was really the only guy at Valve. As far as integration, you have to give time for. If you're going to outsource, you still need to build your client correctly. Now, you could throw your code over the wall and let somebody else integrate, or you can, like what I ended up doing on some of the authentication stuff was, luckily we're in the same city basically with the One guys, is call up one of their engineers and say, hey, get your butt over here. We're going to sit down, we're going to write some code. And that worked really effectively. Actually, integration at this point I think is a really quick thing for most of these back-end services. Again, like the GameSpy guys and the One guys, they have all of these back-end services already deployed. They have SDKs, they have published protocols, they have staff that are willing to help you out. You can sort of minimize your pain if you're willing to look for solutions that aren't, if you're not going to abide by the complete, and this is a game developer thing, the not invented here phenomenon. If you're willing to sort of make a good cost-benefit analysis about whether you need to be spending your time writing those systems, I think it's something you need to look at really seriously. Outsourcing sort of makes sense for a lot of these types of things.
Okay, thanks a lot.
Both GameSpy and One with our SDKs, we estimate anywhere. Both GameSpy and One, we estimate anywhere from hours to just maybe a day or two to integrate most of our technology. Is that right?
Yeah, like I said, it's really matured.
You mentioned the social engineering that the hackers did. Could you talk about that a little bit?
The social engineering?
Yeah, what they tried to do to get you to drop
what
your
happened was
authentication.
when we shipped Half-Life, we had the authentication on, and well, actually, before the boxes hit the shelves, we had people trying to hack the authentication system, like thousands and thousands of keys being guessed. And the nice thing about requesting the certificate and having it be multi-part is it takes more than a tenth of a second to do this exchange. And so it makes it really hard for them to do random guessing. So they turned, of course, to the next, actually probably the most predominant way to hack things, and that's the social engineer. And what they did was essentially organize letter writing or email bombing campaigns to Valve and to Sierra saying, this system is horribly broken, you are screwing your legitimate customers, you must turn it off now. And then they would list people who had had problems. Of course, we would follow up with those people, and the ones who weren't 14 years old, obviously, and lying, we really never got somebody who had a legitimate problem out of this. And there was some fear, I think, not at Valve. We were pretty sure the system worked, but I think at Sierra, I think the one guys were fine with this too. Sierra was really worried about this because I don't think they'd had a game sort of on this magnitude in a while. And then they had this like hate mail campaign, and they hadn't seen that kind of reaction to any product. And so they were they were worried for a while. And as soon as we sort of like followed up with all these people, and pretty much every one of them was totally a liar, we just decided we must have been on to the right thing, and we publicly said, we are not doing anything with this system. It stopped really quickly after that. Just an amusing story.
I have a worry about, as a consumer, when you buy a game like this, you're sort of hoping that the game developer will keep this expensive running server up and running for years to go. I mean, Half-Life is becoming of age, and I guess the sales must be dropping, and at some point it won't be in your interest to keep this going. And at that point, maybe the mod makers like Counter-Strike will still be an interesting place for gamers. So what are your plans about that? Will you open source the server and let other people start servers if they want to? Or what do you feel about that?
The thing about the Half-Life community actually is, I don't know how the retail package product is doing, but the online community has grown since the moment we released it, and it's still on the way up. And we've done a lot of things to foster that by releasing incremental updates to our product, releasing new maps, releasing new mods, and we really plan to continue to do that. Now, that said, I don't think this is going to be an issue, but if it does become an issue and, let's say OneNet blows up, Valve goes out of business, are we going to leave our customers stranded? I don't think so. I think at that point we would turn the whole system off and say, you guys are free to do what you want. With that said, though, I don't think we're anywhere near that with the lifespan of Half-Life. The product continues to do really well. The way we look at TF2, at least, is that it will sort of advance this platform and be based on the same kind of platform and the same issues. We don't want to alienate there'll be a lot of people who will try TF2 and say, I still want to play Team Fortress Classic. Are we going to turn off Team Fortress Classic when we ship TF2? I don't think so. I think essentially you'll be able to play the classic, Valve games until there's no interest for them. We'll just continue to move the platform forward and can keep the compatibility going until there just isn't a market for it. And then we'll probably, kill it. Okay, I think I'm over time, so I can meet people down here if you want to ask more questions. Thanks again for coming.